welcome back to my channel, and in this video we are going to see the time complexity of having three loops. Let's see how do we solve these types of problems. In the previous part 1, I have told you that how to find the time complexity of order of n, order of log n, and we have also seen order of n square. But in this video, we are going to see for order of n cube. I mean, where we are having three loops. In the last, I have brought a bonus question, so please don't miss out that bonus question and watch the video till end. Now let's get started. In the first question, all loops run n times. Let's see. This is the first for loop. This is the second for loop. This is the third for loop. The first for loop runs from 0 to n, which is n minus 1. J also runs from 0 to n, that is n minus 1 times. 0 to n. So n minus 1 times because it is less than n. So for all of these things, you need to remember that time complexity would be the product of number of times I runs and j runs and k runs. So for this, you simply have to write the variables you are having in your for loops. So they are I, j and k. I starts from 0 and goes up to n minus 1. So 0, 1, 2, so on up to n minus 1. The same goes with j. It starts from 0, 1, 2 and so on up to n minus 1. The same goes with the k. 0, 1, 2 so on up to n minus 1. So all the three run 0 to n minus 1 means it runs n times. So that means I runs n times, j also runs n times and also goes with the k. So the value of this is n cube. Therefore, how do you write the time complexity? It is order of n cube. Now let's go to the second example. The second example states that inner loop depends on the outer loop. What is meant by dependency? See, the value of j depends on the value of I, which is the outer loop. For the value of I, this would be the inner loop, obviously. Now, for the value of these two, this would be their inner loop. So, here the value of k depends on its j value. Now, let's see how do we start it. The same. The first rule is writing I, j, k, like all the variables of different for loops. Now I goes from 0 to n minus 1. So it is 0, 1, 2, 3, so on up to n minus 1. The value of j goes from 0 to j less than I. So when you put j less than 0, because the first value of I is 0, so it doesn't run. When you put the value as j less than 1, so only j equal to 0 runs. So 0. Next, it would be 0 to 2. So 0 and 1 would run. So 0 to 1. Next would go from 0 to 2. So this is basically I minus 1. If you observe this, it is I minus 1. So as you go on, 0 to n minus 1 because I value is n minus 1. So it becomes n minus 2. Coming to the k value. The starting value of k would be, since it doesn't go inside j, so k value will also be not printed. So coming to 0, when k is less than 0, but the k value starts from 0. So the condition would obviously become false. So this also would not run. Coming to k less than 1, when the value of j would be 1, then it would be k less than 1. So that time this would run from 0, 0. The next time it would run from 0 to 1. So this is like j minus 1. So in the same way at the end it would become 0 to, what is the value of j over here? N minus 2. So n minus 2 minus 1, because it is j minus 1. So it is n minus 3. So multiplying all these three terms, this I, it runs n times. Now the value of j runs n minus 2 times. The value of k runs n minus 3 times. So you just have to take the highest power from the following equation, that would be n cube, because all other terms get neglected. For time complexity, if some equation is like n cube plus n square, then what would be its time complexity? It would be order of n cube, because you neglect all the powers which are less than this. So here also we take only n cube. So time complexity of this equation becomes order of n cube. Now let's go to the next question. The third example says one loop runs constant times. See, the value of I goes from 0 to n minus 1. J goes from 0 to n minus 1. But the value of k is 0 to less than 5. That means the value of k runs 5 times. For any number of I value or any j value, the k value is fixed. That is, it runs only 5 times. So let's see how do we solve this problem. We write I, we write j, we write k. The value of I goes from 0 to n minus 1. So 0, 1, 2, 3, so on up to n minus 1. The value of j goes from 0, 1, 2, 3, so on up to n minus 1. The value of k is constant, as I said before, because it is going from 0 to 5. That means it runs 0, 1, 2, 3, 4. So 5 times. So for any value of j, it runs 5 times. So now 0 to n minus 1 is nothing but it runs n times. The value of j also runs n times. The value of k is 5 times. So it is 5n square. We ignore the coefficient term. So the time complexity of this code becomes order of n square. Now let's go to the next question. In this question, the inner loop halves each time. Let's see what does it mean. Coming to the I, it goes from 0 to n minus 1. J also goes from 0 to n minus 1. But the value of k gets half each time. Let's see how do we solve these types of problems. I, j and k. So I starts from 0 to n minus 1. So 0, 1, 2, 3, so on up to n minus 1. The value of j goes from 0 to n minus 1. So 0, 1, 2, 3, so on up to n minus 1. The value of k goes from n to greater than 1. So each time it becomes half. So first time it was n, second time it becomes n by 2, third time it becomes n by 2 divided by 2, that is becoming as n by 2 square. So at the end, for particular number of iterations, so this value would become n upon 2 power p. Suppose if we are taking for p number of iterations, then it would become n upon 2 power p. So to find the value of this, we need to write it as n upon 2 power p. So this would be the value of k now. So for this value, we need to separately find the time complexity because it is something unknown power. We can't write it like that. So we need to find its time complexity separately and then multiply with these two things. So let's see. When this condition would become false, at that time the loop would stop. So we have to take the condition where the loop gets false. At that place we'll get its time complexity. So it is k greater than or equal to 1. I'll tell you the reason why k greater than or equal to 1. See, for k greater than 1, the value is true. But what would be its false value? 1, and less than 1 would be false. We know that k greater than 1 value is its true value. So its false version would become k less than or equal to 1. We know what's k value. It is n upon 2 power p less than or equal to 1. So which is n less than or equal to 2 power p. So this is 2 power p nearly equal to n. If you send exponential to the other side, it would become logarithmic function. So p is equal to logarithm of n base 2. So here we have got this as logarithmic of n base 2. And how many times the value of j would run? 0 to n minus 1. So it is n times. I also 0 to n minus 1. So it runs n times. So it has become n square into logarithmic of n base 2. Therefore, the time complexity is order of n square log n base 2. Now let's see the next question. It is saying that it has different limits. See, the value of I goes from 0 to n, j goes from 0 to m, the value of k goes from 0 to p. So now let's see the same process. I, j, k. I starts from 0 and it goes up to n minus 1. J starts from 0 and it goes up to m minus 1. K starts from 0 and it goes up to p minus 1. So I runs how many number of times? N times. J, m. For k, p. So the time complexity is order of n, m, p. Now we have come to the bonus question of this session, and let's see how do we solve this problem. The value of I is 1 to n, j is from 1 to I square, the value of k is from 1 to n by 2. See, this thing is constant. It always runs 1 to n by 2 times. So the process is same. I, j, k. Value of I is from 1, 2, 3, so on up to n. Value of j is from 1 to less than or equal to I square. First time when you put I is equal to 1, it goes from 1 to 1. That is just 1. When you go to the next time increasing I value, it becomes 2. 2 square would become 4. So this time it runs from 1 to 4. So 1, 2, 4. Next time it would run from 1 to 3 square, that is 9. So on, what would be the last term? 1 to n square. Coming to the value of k, it would always run from 1 to n by 2 for all the following cases. So at last, the value of I runs n times, the value of j runs n square times, the value of k runs n by 2 times. That is equal to n power 4 upon 2. Therefore, time complexity becomes order of n power 4. So the thing I want to conclude is, even though we are having 3 for loops, this time the order hasn't come as order of n cube. So that doesn't mean that having three loops gives the answer order of n cubed all the time. We have seen the different cases where we have got order of n square. Sometimes we have got it as order of n square log n. So it depends on the problem and the condition of the variables. So that's it for this video. Hope this was useful. If you like the video, then please share it with your friends and comment your opinion below. And don't forget to subscribe to our channel. Bye bye. See you soon.